Okay, let's give you guys some practice now. So find a way to represent e to the power of x as a Maclaurin series centered at x equals 0. Okay, so just a reminder, we've seen this in the past. We would start out with with a constant, and then x to the power of 1, x to the power of 2, x to the power of 3, 4, 5, and so on, all the way to infinity. We would then differentiate each one, and then with our original function, in our case, this time around it would be e to the power of x. We would differentiate it, e to the power of x, and so on. And then we demand that the derivative of this matches up with the derivative of this, the second derivative matches up with the second derivative, and so on. That then led us to this. So rather than having to do this from scratch, just use this formula. So remember, this formula can be summed up as this. So overall, hang on. So find a way to represent e to the power of x as a Maclaurin series. So just jump to this formula. Okay, so well, anyway, press pause and have a go. Okay, so to do this, we need the first derivative, we need the second derivative, third derivative, and so on. So you would start out with the original function. The original function is this. Differentiate it, so that will then give you your first derivative. Differentiate it again, that will then give you your second derivative. But our function would be the original function evaluated at 0. So the original functions here evaluated at 0. So that would then give us e to the power of 0, which would be 1. So this block here would be 1. And then for the second one, for x to the power of 1, for the second coefficient, it would be us looking at the first derivative, which would be this one here, evaluated at 0. So evaluated at 0, so that would be 1. So the coefficient here will be 1, and then you've got your x to the power of 1. So that would be 1 times x to the power of 1, which would be x. And then for this one here, we will need to look at the second derivative. Well, the second derivative is here. Hang on, let me clear this up. So we would need to look at the second derivative evaluated at 0. So the second derivative evaluated at 0. So that would be 1. So this block here would be 1, and then you've got your 2 here. So it would be a half, and then you've got your x squared here, x squared. And then for the third one, for the fourth coefficient, we need to look at the third derivative. So the third derivative will be e to the power of x evaluated at 0. Evaluated at 0. So we've got to put 0 into the x here. That will be 1. So this thing here will be, this block here will be 1 over 3 factorial x to the power of 3. And then this one here will be 1. 1 over 4 factorial x to the power of 4, and so on, all the way to infinity. So we can represent e to the power of x as this series, and then you can tidy this up by writing it in this form here. So what that means is this. What that means is you start out with your original y equals e to the power of x. So this red line here is our e to the power of x. So if you look at just the first two, looking at the first two, that will approximate to this, which is not that good. But then if you look at the first three terms will then give you this. So can you see around here it's getting better now. It's getting better. And then if you look at the first 4 terms, that will then give you this. Now it's getting closer and closer to e to the power of x. The thing is, as you head towards infinity, the whole thing here will map on top of e to the power of x. So looking at this, looking at the first 4 terms, that will then give us this. That will then give us this purple line here. That will then give us this. And then now if you look at up to x to the power of 4, that will then give you this. So it's getting better and better each time. And as you head towards infinity, the series will map on top of e to the power of x. So you can represent e to the power of x as a series. Okay.